Right, I think that is us live. Doo-doo-doo. So, hey all, welcome to IOX Office Hours once again. This is going to be a quick and easy, quick fire one for you now, which is downsampling with serverless. Just a little bit of housekeeping before we start. If you want to watch any of these videos back, you can find these in the live recording section of the YouTube channel on InfluxData's account. So they're always there, and all the other office hours that we've done are always there. I think we've done intro to Apache Arrow, we've done intro to pandas, we've done the IOX data schema model. So you can always go back and revisit these afterwards. The last thing, just to make sure that you know, is we'll actually be at KubeCon in Amsterdam next week. So if you're around or plan on attending, we will be there and look forward to hopefully seeing you. So without further ado, downsampling with serverless. If I can actually get this to move. Let's see. There we go. So I thought before we start and drill into the code, we would actually sort of level set on what serverless compute engines actually are. Because you could be coming at this directly from InfluxDB and go, hey, I just need a task engine. I need it to run in the cloud. How can I create this, or how can I deliver this? So what a lot of the great cloud providers have done is provide a series of services that allow you to run basically infrastructure as a service or your containers as a service within their cloud infrastructure. Now, essentially what they mean by as a service is they essentially handle all of the underlying infrastructure, so you don't have to. So you focus on building your code, and it will automatically provision and scale and manage the resources needed to run your code based upon the amount of traction or the amount of work it needs to do. So this was my favorite cheat sheet that I found. I did not create this, mad props to the person who did. But as you can see, there is a series of depending on what you need as a service, you might start off with some infrastructure if you need most full control. You could have containers as a service, platform as a service. But the one we're going to talk about today is a function as a service. And these really boil into three main areas for each of the cloud providers: a Lambda for AWS, an Azure function, and a Google Cloud function. And these enable you to run a short script or an API of some form, a short piece of code. It's normally event driven and it's stateless, so it's short-lived. And we're going to use this to transform our data or query our data, transform it, and then write it back into InfluxDB, also known for us as, in this case, we're going to be doing it as a downsampling task. So as we said, there are three. We have AWS Lambda, Azure functions, and Google Cloud functions. You can also do something similar just with containers if you don't want to deal with clouds directly. Cloud-based functions directly. But we're going to focus a lot on AWS Lambda today. So just so we can bring it down into a problem area so you can see exactly why this is useful, let's have a look at a serverless architecture and what it might be. So in this serverless architecture, we're building a platform called Plant Buddy. And in this, what we'll have is a Plant Buddy application which users can access on their phones. And what it will do is it will allow them to monitor their household plants. Essentially, what the user will do as normal is create an account. This would be stored within, say, a normal UserDB, a relational database. And then we'd be using InfluxDB to store the sensor data or the time series data being produced from the sensors that are measuring the health of our plant. This is going to be stored in a database called sensor data. And then we have a bucket called downsampled, which will be our front-facing bucket and where we will aggregate our raw sensor data. And then we have a series of Lambdas that connect all of this platform together. We have a user management Lambda, which works between creating, logging, and sign up and storing that within the user database. And then we have a get plant health Lambda, which takes a user ID, queries InfluxDB's downsampled bucket to retrieve the sensor data. Now, I'm being very trivial here. There's obviously a lot more within the architecture. that this platform would need to do. This is just a very high level snapshot of the way the architecture is working, just so you can get an idea of how we're using Lambda here. The Lambda that we're going to focus on, though, is the downsample Lambda. So why might we want to do this? Well, if you imagine our sensors are reading data every second, so we're getting the temperature and the moisture of our plants every second. Now, it might be great to have this raw data stored away for our own devices, say for machine learning or to do some forecasting. But really, the user doesn't need that sensor reading second by second when we're dealing with moisture or temperature sensors on this level. They're really only going to fluctuate maybe, even an hour, or like a minute at most, or even an hour to, a day in terms of fluctuation. So what we can do is we can aggregate that data. Say if we take the average of that data for a day or for an hour or for a minute, and then we're going to store that data within the downsample bucket. Once the data is within the downsample bucket and stored there, we can use that for quick retrieval and send that back to our user. The benefit of doing this here is we don't actually have to perform an aggregation directly on the raw data bucket and perform an aggregation query there. We can do that ahead of time and then just do a very simple get query for the downsample data. So that's one of the benefits of having an automated downsample bucket. A lot of other people use, especially customers, use downsampling for, say, if you want to keep your high fidelity data for an only certain amount of time. So say you want to keep all of your tracing data for maybe 7 days, and then you want to take a subset of that data, an aggregation like snapshot view of that data, and store it in a much longer retention bucket, then you can do so through downsampling. And so essentially allowing you to store historically large amounts of data without needing to worry about the granularity or the size of it. So moving on from there, how do we go about creating one? So what we're going to do is we're actually going to use AWS Lambda to create our downsample function. Now, I'm going to show you the command line way of doing this a little bit later, but here's the UI method just to take you through it. So what you're going to do is when you log into your AWS console, you're going to search for AWS Lambda, and you're going to create a new function. Can you guys hear me now? Oh, that is gutting. So did we hear any of it, or was it all gone? So how much did we hear up to what slide? Did we did we hear any of it, or was it all muted? So last 6 minutes ago. Hey Anais, do you have a specific slide where we lost it, and I can quickly just cover that last bit again? So what I will do is I will just quickly fire through the last bit of this, so you can hear me here. So all we discussed at this point was, so this is the actual script for downsampling. So you import your dependencies. We have our Flight SQL client here, pandas, our InfluxDB client, and the specific part that we're using out of here is our write API. You deliver your authentication credentials, so your token, your URL, your org. In this case, we're specifying the raw and the raw bucket and the downsampled bucket. The token we recommend storing in something like AWS Secret Manager rather than actually explicitly providing it within the Lambda. I'm back for a drop tip at create function. Basically from the first code slide. Okay, thanks guys. Sorry about that. So I'll quickly just recover this little bit again, just to make sure that everyone gets to see it. I'm ever so sorry for those technical difficulties. So once we have our credentials there, essentially what we're going to do is we're going to establish a Flight SQL client. In order to do this, we provide the host, the token, and the most important thing here is the metadata. The metadata for us is how we specify the location of where our data is within InfluxDB. So we use bucket name, which is essentially your database, and we're going to specify our raw bucket to pull to, and that's where we're going to be querying our data from. Next, what we're going to do, sorry, please ignore this bit here. This isn't a copying error. We're going to be looking at number 4. We're going to create our query. And essentially, when we're creating our query here is what we're going to do is we're going to bin our data, which in other words is windowing our data. So we're going to window our data into 1-minute intervals. And then we're going to take the average humidity, temperature, and moisture within those 1-minute intervals from the table plants. From there, we're then going to say we only want to do this for the last hour's worth of data. And we're going to group by bin, which means we're going to basically take all of those raw values in humidity, temperature, and moisture, make sure that they're grouped within the bin windows, and then we're going to then take the average for those, which is essentially the window there. Now, just so you know, the reason why we used bin rather than just grouping by time is based on how SQL orders their essentially how SQL orders its groupings. If we grouped by time, it would group time before we actually did our date bin. So this is why we use the bin label in order to do our grouping. It's an interesting way SQL does this, its grouping there. And hopefully Anais might be able to correct me if I'm wrong now, if that has changed for us in the future, or if there's a better reason why. That's from my understanding of how SQL works. So finally, what we're going to do is then we're going to create a reader to consume our results. We do this through a client do get, and then we provide a ticket. So this is the exact ticket of where we're going to be pulling our data from InfluxDB IOX. We then read that data in as a PyArrow table. We're then going to convert that table to pandas. The cool thing here is PyArrow is extremely fast at serializing and deserializing. So we have an extremely efficient method for serializing into a pandas data frame. We're then going to sort our values by time. And then we're then going to create an InfluxDB write client. This write client will then take our pandas data frame. So our write client has the ability to consume pandas data frame and convert it to Lime protocol. So essentially all you need to do is specify record equals the data frame, so the variable that's holding the data frame. And then we have our data frame underscore measurement underscore name, which specifies essentially the measurement name or table of where the data is going to be written to. And then we're also going to specify the timestamp column, so the actual time column. Now, there is a bit of code missing here. Since we renamed the time column bin, we're going to have to rename that to time. So sorry, that bit of code is missing there. Essentially, we can do that really easily within a pandas. We can rename the column name within pandas quite easily. So from once we do this, we write that data directly back to InfluxDB. Oh, and also just to specify, we specified that we're going to be writing the data into the downsample bucket. It's also worth noting, you could just all store the data all within one bucket and just have multiple tables. The reason that we might want to store them in different buckets is we have a token system within InfluxDB IOX. So you might want to say, you might want granularity of who can access what based on tokens. So now that we have our code created, we're ready to deploy that code. Now, I don't know if you probably missed this, but just for code completeness, essentially what I've also provided is the command line way of also creating this Lambda function. So you'll need the AWS CLI in order to do this. But essentially what you're going to do is almost like creating a Python application locally. So you can do a make the downsample, you CD into that directory, you create a Python environment, you install the dependencies that you need, you then create the downsample.py file, you add the code like we've just specified, and then all we're going to do is we're going to package up those dependencies that we require. So we're going to CD into our environment file. So our virtual environment. We're then going to zip up those the functions that we require. We're then going to CD back out, and then we're going to zip up our function.zip alongside our lambda.function.py. Once we've done this, we can then use the AWS Lambda function to create, AWS Lambda create function to create our Lambda. So our function name, our runtime, our role, our handler, and our zip file. So last, just to specify, once we've created our Lambda, you still need a way of activating that Lambda. It just sits there waiting for an event or a trigger to be able to process. So we have CloudWatch and EventBridge are two options to allow you to schedule a trigger or like a cron job, as you will, in order to trigger this. So definitely check out both of those methods. We can leave links to the instructions on how you can do that with CloudWatch and EventBridge in order to trigger a Lambda. I highly recommend checking out Anaïs's blog on this. They basically link to the guides on how to do this. So, and there you have it. Here is an example of our table. Please note that bin here should be time. This is just based on how I've queried the data within our SQL interface. So that should be time. But you can see now we have our minute intervals or our minute windows and the averages for our humidity, moisture, and temperature. So what next? What we were saying here is we've actually started to create a new library called PyInfluxFree, which merges those two libraries that you saw today together. So it merges the Influx client write part of the library and also the Flight SQL query part of the library into one package install that you can basically use together as one package. So I've just added the ability to deploy it via pip, so you can just install that directly. It's a community-driven library, so if you would like to contribute to it, we would love to see some pull requests and any ideas that you have. That would be great. So highly recommend checking that out in order to create your Lambda. Also, if you haven't signed up for IOX yet, definitely get signing up. That is where you can leverage unlimited cardinality and flight SQL. We also have our Influx community. This has a series of examples and sample data that you can try against IOX. So definitely check that out to get you started with some of these examples. I've also left an Arrow task engine there, which is basically a containerized version of a Lambda. So it just uses Docker containers in order to basically query your data, transform it, write it back to InfluxDB. So definitely check that out if you don't want to use one of the cloud services. Lastly, on community, join our Slack community if you haven't already. We're always out hanging out there. You can talk to us there directly if you have any more questions, and join InfluxDB University if you want any more course material. Essentially, we'll be releasing an InfluxDB IOX Essentials course soon. We're almost finished with that. We're just in the process of putting that through Q&A, so you'll be able to leverage that soon enough. So hopefully we now got some of it. I'm ever so sorry for the mic cutout. That never normally happens, so my apologies. But if you have any questions or any questions relating to IOX at all, myself and Anais are here to answer those questions. And just a reminder as well that we will be at KubeCon next week. So if you're about at KubeCon, please do not hesitate to come and see us there as well. That would be great. Right, I will hang around for a little bit, and then if you don't have any questions, then we'll end the stream for this one, and I'll make sure I buy a new mic. That was pretty bad. Awesome. Well, if we have no questions, then I will call it to a close. And yeah, if you have any further questions, just reach out to me on Slack. Please don't hesitate to ask any questions there. And I hope you guys all have a great Thursday evening or morning, depending on where you are. Thanks, guys, and sorry about the mic issue once again.